we're going to solve some quadratic inequalities. So we know it's a quadratic because it's got an x squared term in it. So it's got a squared term, that makes it a quadratic. And if it's got a greater than sign or a less than sign, then that means it's an inequality, it's not equal to 0. Now, the key word for solving these ones is you have got to draw a sketch. You've got to draw down your parabola because you've got to read your answer from your graph. Right, we'll go through these and we'll do a few of them. So the first one we've got here is, by sketching the parabola, solve the equation. So we've got x squared minus 4x is greater than or equal to 0. So the first thing we do is we make it x squared minus 4x is equal to 0. We can factorise it. There's only two parts there, so that means that it is a common factor, and the common factor is x. So we'll get x bracket x minus 4 is equal to 0. So if we get these two things multiplied together, that could be a bracket with x minus 0 in it. So all you do is you write down x is equal to 0 for that one. And that one becomes x minus 4 equals 0. We've already got our answer for that one. We've got to do a wee bit of work in that one. Add 4 to both sides, so x is equal to 4. So what we've now got is, we have got our two roots. So we'll draw down the x-axis and the y-axis. So there's the x-axis, there's the y-axis. I've got a root at 0 and I've got a root at 4. Now it's a positive x squared, so that means we have got a U-shaped parabola. It's a happy one. Now, when we have greater than or equal to 0, that's the bit above the x-axis. But because it's also equal to 0, it's on the axis. So it's that point and all of those points there. Now it's two separate bits, they're not joined. So we've got this bit here to describe, and we've got this bit here to describe. Now, that is the origin, that's 0, and that was 4. So describing all the x numbers that would go along there, so all the ones, if I drop them down to read them off the x-axis, those are all the x values that are less than 0. If I drop down to read all the x numbers off this axis, they're going that way, so they're all the ones where x is greater than 4, and that's it solved. Now, because it's also equal to, we'll put the equal sign in as well, and that's it, finished. This one here, x squared plus 14x plus 33. I'm looking for factors of 33. It's positive. It's got to be 1 and 33. 2 doesn't divide into it, it'd be 3 and 11. So I'm going to skip on to factorising that. Okay, you can do it the long way if you want. So basically the factors of that one are x and x, and it's going to be plus 3 and plus 11. And I know that because it's got to come to 14 and it's positive. So what we've got then is, we have a parabola, same as the last one. It's got to be U-shaped. We want to find out what our roots are. If that's all equal to 0, then that makes x equal to negative 3. That makes x equal to negative 11. So we've got a parabola that is cutting here at negative 11. And at negative 3, it's just a sketch, so it doesn't need to be drawn to scale in any way. We want the bit where it's less than or equal to 0. So less than is the bit below the axis, or the x-axis I should say. So it's that continuous bit. So only one part to that. What is that described as? The x numbers are the numbers between negative 11. So draw x in between negative 11 and negative 3. And the arrows always go that way. Now we check there's an equal to sign there as well, so we need to put an equal to sign in there. Okay, for this one we've got x squared minus x minus 20 is greater than 0. We're going to make that equal to 0 so we can factorise it and solve it to find the roots. And I'm looking for two numbers that multiply together to give me negative 20, and a combination of them gives me negative 1. I'm going to skip all the working and just write down your factors. So it's going to be 5 and 4, and it's got to be negative 5 and plus 4. And you can do that the long way. So either x is equal to, and you'd always write this down in your test, don't miss out that wee step. Okay, I might miss it out in these videos, but you must write it in the test. So x is negative 4, x minus 5 equals 0, so x is equal to 5. So I've got two roots. I've got one at negative 4, and I've got one at 5. A sketch doesn't need to be drawn to scale. So it's a positive x squared term, so again it is U-shaped, it's a happy one. Now I want the bit where it's greater than 0. Greater than 0 is the part above the x-axis. So the bits of that graph that are above that x-axis is that bit there and that bit there. Two different distinct bits because they're not joined. That's a bit and that's a bit. So how do I describe all the x numbers for all of those points? And remember that goes on and that goes on and on. So that's all the x numbers that go in that direction. So x has got to be less than negative 4. And these ones would be all the x numbers that go along there. So that's going to be x is greater than 5. Okay, next one, x squared minus 9x plus 8. So I'm looking for two numbers that multiply to give me positive 8. And we're going to make it equal to 0. And they give me negative 9. So it must be negative 8 and negative 1. So I can just do negative 1, negative 8. So either x equals 1 or x equals 8. I'll draw them in as my roots. So there's a root at 1, there's a root at 8, and it's a positive. So I've got the U-shaped parabola that looks like that. I want the bit less than 0. Remember that less than 0 is the bit underneath the x-axis, so underneath here. The part of the graph that's underneath the x-axis is that bit there. It's one continuous bit. How do we describe it? All those x's lie in between 1 and 8, and we put our arrows in that way. There's no equal sign, so it just stays as that. For this one here, there's only two terms, so it's either a common factor or a difference of two squares. X squared is obviously a square, there's the difference, and 16 is 4 fourths, so that is a difference of two squares. So we'll make two identical brackets, take the square root of x squared, which is x, take the square root of 16, which is 4, and we make one bracket positive and one bracket negative. We'll make it equal to 0 to solve it. So either x plus 4 equals 0, or give me x equal to negative 4, x minus 4 equals 0, give me x equal to 4. So two roots, one here at negative 4, one here at 4. It is still a positive x squared, so it's still a happy one, so it does that. I want the bit of the graph that is greater than or equal to 0, so greater than 0 is above the axis. The equal bit means that I'm taking these numbers as well. So all the bits of that graph that are above that axis, they're there. That goes on and on and on. That goes on and on and on. So how do I describe all those x numbers? If I could read them off, they're starting there and they're going in that direction. So x is greater than 4. All of these ones are going that way. So they're going as x is less than negative 4. Now there's an equal to sign on it. So we've got to put an equal to sign on these ones as well. Next one, 3x squared minus 27. Only two terms. We'll look for a common factor. Common factor of 3. So that would give me x squared minus 9, and I'm making it equal to 0. Divide both sides by 3. 0 divided by 3 is still 0. So that just comes down to x squared minus 9. It makes it much easier. Difference of two squares. Take the square root of x squared, which is x. Take the square root of 9, which is 3. Make one bracket positive, one bracket negative. So x plus 3 equals 0. That would make x equal to negative 3. And x plus 3 equals 0. Add 3 on both sides. X is equal to 3. So two roots. There's negative 3. There's plus 3. And it's positive x squared term, so it's still a happy one. I want the bit that's less than or equal to 0. Less than 0 is the bit below the axis. So the bit below the axis is all of that bit there. It's one continuous bit. So it's all the x numbers that lie between negative 3 and plus 3. And the arrows always go that way. But because there's an equal sign on there, we put an equal sign in there. That means that you're including 3 and negative 3 in your calculations. Now, this one, because it's a 2x squared, we're not going to miss out any working, okay? So we have to fill it all in. So we've got 2 times -3 is -6. Factors of 6 are 1 and 6, and 2 and 3. The next one would be 3 and 2. We've got them all. Negative means that they've got different signs. So either the negative sign goes with that 1, or the pair that would match that would be 1 and -6. Negative sign with the 2, the pair that would match that would be 2 and -3. I'm looking for the pair of factors that give me positive 5. So positive 5 must come from these two here. -1 plus 6 is positive 5. So we'll split that up and we'll do 2x squared minus 1x plus 6x's minus 3, and I'm going to change that to equal 0. Break it down the middle, highest common factor there is x, so it's x bracket 2x minus 1, and here we've got a highest common factor of plus 3, which would give me 2x minus 1, and pair of brackets together, so x plus 3, doesn't matter the order, and 2x minus 1 equals 0. So either x plus 3 equals 0, take 3 away from both sides, so x is -3. This one here, we've got a wee bit more work to do. 2x minus 1 equals 0. Add 1 onto both sides, so 2x is equal to 1. Divide by 2, so x is equal to a half. So when we draw this one down, we've got a minimum turning point because it's still a positive x squared term. So we've got a -3 root, and we've got a half. And we draw a parabola, so the parabola is still a happy one, it does that. It's less than 0, the bit below the x-axis is less than 0. So the bit that we want is this bit all below the axis. It's a continuous bit, it's not two broken bits. So to describe that, we are going to describe that as x lies between -3 and a half, and the arrows go that way. Just check there's no equal sign, so that's our solution. Now the next one, this is the first one I've done with a negative squared term. So negative squared term, unhappy, it's a sad face. But what we can do is we can take that all over to the other side, make it equal to 0, take them all over to the other side to make it a positive x squared. So add x squared onto both sides, that becomes positive. Add 6x onto both sides to get rid of that one, and take 7 away from both sides and make it equal to 0. So basically I've changed the sign of all of them and I've put the x squared first. So now we're looking for two numbers, factors that multiply together 7. 7's a prime number, so it can only be 1 and 7. But because it's -7, it means that we've got one factor that's positive and one that's negative. It's got to be -1 and +7 because the biggest number carries that sign of the middle term. Because it's 1x squared, I can just go on and I can say x and x, my two factors are -1 and +7, make it equal to 0. X minus 1 equals 0, giving me x equal to 1. X plus 7 equals 0, giving me x equal to -7. Draw down your graph again. Put in your roots. So we've got a root at 1 and 1 at -7. So there's the -7 one at the negative side. And then we've got a wee one at 1. Not drawn to scale, but it doesn't matter. So x-axis, y-axis, it's a negative x squared. So remember, we're drawing the unhappy one. It's negative. And we want the bit that's greater than or equal to 0. Greater than 0 is above that axis. Equal to 0 is on it. So what part of that graph is above the axis? It's this whole bit here. There's only one bit of it. It's continuous. How do I describe it? I describe it as x is in between the two roots, which was -7 and +1, and the arrows go that way. But it was also equal to, so we put the equal to sign in there. I'm going to put in a wee extra one in here that's got a negative x squared term. So we'll start off, we'll make it equal to 0. So 50 minus 2x squared equals 0. And two bits, so it's either a common factor difference of two squares, or it could be both. I can see a common factor of 2. Pull out 2 gives me 25 minus x squared. And when I do that, I can see that that's a difference of two squares. 5 5s are 25, and that's obviously a square with a difference, a minus between them. Divide both sides by 2. When I do that, that goes, nothing divided by 2 stays as nothing. Now, we want to take the square root of each of them. Keep it in order. So the square root of 25 is 5, and square root of x squared is x. But remember, we make one bracket positive and one bracket negative. So for this one here, I've got 5 plus x equals 0. I don't want that 5 to be there. So I'm going to take 5 off both sides. So x is equal to negative 5. This one here, just be careful with that one. 5 minus x equals 0. I'm going to add x onto both sides. So reading it round the other way, x is 5. So now we draw our axes down. There's your y-axis, there's your x-axis. We've got a negative x squared term. So I've got a root at negative 5, I've got a root at plus 5, and it's negative, so it's unhappy. It's a maximum turning point like that. I want the bit that's greater than or equal to 0. Greater than 0 is above the axis. Find all the parts of the graph that's above that axis. It's those bits there. It's one continuous bit. So describing all of those x numbers in there, they lie between negative 5 and 5. Arrows always go that way. And there's also an equal to sign there. So we put the equal sign in as well. I'm not going to do these ones, but just be aware, if you've got something that looks like that, you've got to rearrange it. So take 8x off both sides, take 5 away, so you get 4x squared minus 8x's minus 5 is greater than or equal to 0. Do it the same as the ones I've done before. This one here, so for that one there, take all your 3x squared, take it away from both sides, so you get negative 3x squared. Then you've got plus 7x and a plus 6, make that equal to 0. Now change that to a positive by bringing them all over the other side. So you could have then 3x squared minus 7x's minus 6 equals 0, and it's easier to factorise the positive one. Right, done the same as the ones that I've done just in the last part of the video. Right, this one here, x squared minus k minus 2 times x plus 4 is equal to 0. Find the range of values for which it has got no real roots. So they're telling me no real roots. So what's the condition for no real roots? We've got to write that down. So no real roots when, and that is when b squared minus 4ac is less than 0. Okay, so we're going to write down our a's, b's and c's. And a, that's like a 1 in there. The number in front of x, be very careful, it's that whole thing there. And then c is obviously just a wee bit stuck at the end. Okay, so really what we want here, that's b. So I'll write them down. So a equals 1, b is equal to negative k minus 2. And c is equal to the thing without the x or the x squared, so that's just a 4 in there. I really don't like that b, so I'm going to multiply that bracket out, so it's negative k plus 2. I don't like starting with a negative, I'm going to make that 2 minus k. So that was a wee bit of work tidying that up, but that's my values for a, b and c. So now I can go on and substitute them in here. So b squared is going to be 2 minus k all squared minus 4 times a times c, and it's got to be less than 0. So multiply your 2 minus k times your 2 minus k. I will show you a quick way of doing this. I'm going to do it the quick way. So it's going to be 4 minus 4k plus k squared. So that's the bracket multiplied out. And then minus 4 times 1 is minus 4. Minus 4 times 4 is minus 16. And that's less than 0. Tidy that up. Take the squares first. There's only one k term, so it's minus 4k. Tidy up the numbers. 4 and negative 16. That would give me negative 12. Now to solve that, it's a quadratic inequality. We've got to change it to equal 0 and factorise it. So I'm going to factorise k squared minus 4k minus 12 equals 0. It's a trinomial. What two numbers multiply together is negative 12, and a combination gives me negative 4. So negative 12, we could have 1 and 12, 2 and 6, 3 and 4. So I want a 4. So it's going to be a 2 and a 6, but what can we say about the signs? It must be negative 6 and positive 2, because that means that both factors have got different signs. So because it's just a straightforward k squared, I can do k plus 2 times k minus 6. That's equal to 0. You would do k plus 2 equals 0, giving you k equal to negative 2. K minus 6 equals 0, giving you k equal to 6. Now, it was a positive x squared term. We're going to draw it down. It's going to be a happy one. So when I draw that down, I've got a root at negative 2. I've got a root at 6. It's a happy one, so it does something like that. That's your x, that's your y. And I want the bit where it was less than 0. Less than 0 is the bit of the graph below the x-axis. So it's that continuous bit of graph there. It's all one. It's not broken. It's all continuous. So how do I describe all those numbers in there? All those x numbers, if I had to read them on the scale? I'm describing them as x is in between negative 2 and 6. So x is sitting in between negative 2 and 6. The arrows always go that way. And just check if there's an equals to. There isn't an equals to there. It's just less than. So that's your solution for that one.